folks, welcome back to another video. Today we're looking at question 538, convert BST to greater tree. The way we'll be approaching this problem is by using recursion and using a global variable called sum that will keep a track of the sum that we've seen so far. So let's jump right in. We're initializing a variable called sum, which is accessible throughout the entire class. And we will have a recursive method, let's call it helper, and you will pass in the root. And you would be returning the root itself, since that's the signature of the method. All right, so let's look at the recursive method now, since we're calling it helper. And then tree node, let's call it n. All right, so let's tackle the base case first. So if n is equal to null, you would just return as is. You won't really do anything. And the next thing you need to do is you need to call this method recursively on the right. So this call right here on line 18, this keeps happening till you reach the last, the rightmost node in the entire tree. So once you have that, you need to update the value of that particular node with the sum that you see. So at this case, when you reach the rightmost node, the sum will be equal to 0, but you don't really need to add anything, since that will be like the greatest node. You won't really have anything greater than that, so you just keep it as is, and then you'll update the sum to be the new value, since this will keep a track of the sum that you've seen before and the current sum itself. And then once those computations are done, you will call this on the left node. So the way all of this will be happening is by calling the nodes in the right order. So that's the key of the entire problem. So let's quickly compile this and see if it's okay. The first test case is okay. Everything else is okay as well. Awesome. So let's quickly talk about the space and the time complexity. The time complexity of the entire solution is O of n, since we are traversing through all of the nodes in the tree. The space complexity would also be O of n, and this is because of all of the recursive calls that we will be having in the stack. Not really any additional, explicitly using any additional space, but because of all of the recursive calls that we have in the stack. Awesome. So if there are any questions, please let me know in the comments below. And please don't forget to subscribe. I would really, really appreciate that. See you all in the next video. Peace.